If you want to rank these functions, root 3 of x and ln of x power 3, when x is approaching to infinity, we would find the limit of one of them over the other one. When x is approaching infinity. And depending on the answer of limit, we can decide which one grows faster. So if we consider infinity here, we would see that it will be infinity over infinity. So we are thinking of using L'Hopital. It will be limit of derivative of the top. We know that root 3 is the same as x power 1 over 3. So taking derivative means it will be 1 over 3 x to the power 1 over 3 minus 1, which means negative 2 over 3. Over, when we have ln of x cubed and we want to take derivative, we think of this. If it was x cubed, what should we do? If it was x cubed, we would write 3x power 2. But in this case, we would write 3 ln of x power 2 instead of x power 2. And then multiplied by the derivative of the inside, which is ln of x. So derivative of ln of x is 1 over x when x is approaching to infinity. Now, we would simplify somehow to see if we can find the limit or is it still undefined. We would see that 1 over 3 divided by 3 means it will be 1 over 9. And x power negative 2 over 3. And then here, 1 over x is the same as x power negative 1. So it is x power negative 2 over 3 divided by x power negative 1. Following the power rule, it will be x to the power negative 2 over 3 minus negative 1, which means x power negative 2 over 3 plus 1, which is the same as x power 1 over 3. And we would write it here. And also, we would have ln of x cubed, ln of x squared, when x is approaching to infinity. So when we have x approaching infinity, it will be still infinity over infinity, and we can take derivative, so we can use the L'Hopital rule again. Taking derivative of the top gives us 1 over 3 x power 1 over 3 minus 1, which means negative 2 over 3. Over 9 times 2 ln of x power 1 times 1 over x when x is approaching to infinity. So it will be limit of 1 over 3 divided by 18. So it means 18 times 3. Which is 54 ln of x. And for powers of x, same as the previous one, we have x power negative 2 over 3 over 1 over x, which is the same as x power negative 1. So we can use the previous answer, which is 1 over 3, when x is approaching to infinity. Now, check it again if it is defined or is it still undefined. So if we plug in infinity, we would get infinity over infinity again. So it will be limit of when we take derivative. When it is infinity over infinity, so we can use L'Hopital again. it will be 1 over 3 x power negative 2 over 3, as we did a couple of times before, over 54 times 1 over x as the derivative of ln of x. And it will be 1 over 3 divided by 54. It means 3 multiplied by 54. So it will be 2, 6, 1. And the power will be negative 2 over 3 minus negative 1, which is 1 over 3. Don't forget to write the limit and x goes somewhere. This time it is infinity over 162, which is not undefined. The answer is infinity. So limit of one of the functions over the other one is infinity. It means that the top one, which is root 3 of x, grows faster than the other one, which is ln of x cubed. Let's go to another question, which is still about L'Hopital, but not about ranking the functions. If we want to find the limit of x e to 1 over x minus x when x is approaching to infinity, we would see that since 1 over x, when x is approaching to infinity, is going to be 0, and it means the limit. And e to 1 over x is going to be 1. So infinity times 1 is infinity. And we're going to use the technique that we are having 0 and infinity. So we're going to use limit, and we can factor out x power 1 over x minus 1 when x is approaching to infinity. We cannot find this. It will be undefined infinity and also 0, because inside the parenthesis is 0, outside is infinity. But we can use the technique of writing one of them over the reciprocal of the other one when x is approaching to infinity. In this case, we're going to have 0 over 0. So we are allowed to use L'Hopital. We're going to take derivative of the numerator, which is a copy of itself, since it is exponential, times the derivative of the power, which is negative 1 over x squared. Over the derivative of 1 over x is negative 1 over x squared when x is approaching to infinity. So these two will cancel out, and we're left with limit of e to 1 over x, not x squared, when x is approaching to infinity. It will be e to the power 0, because 1 over infinity is 0, and the answer is 1.